Good morning, everyone. How are you doing so far? Having a good conference? Excellent. Aren't you happy to talk about the end of software engineering? You know, I couldn't resist and start this talk actually with a picture that I asked ChatGPT to generate. What does the end of software engineering look like? Well, according to ChatGPT, it looks like this. And then I politely added as we know it, just for a bit of a feeling. Yeah, so what, and I work with tons and tons of companies. So rather than being at one company, I'm actually at a lot of different companies, and I'll explain to you later on why that is. And what I see is two trends. On the one hand, generative AI. Everyone is looking at how do we make better use of AI. And I listened to some of the talks this morning, and of course, this comes up all the time. On the other hand, especially here within Europe, and I know the UK is no longer part of the European Union, but I'm pretty sure you have something similar going on. There is all this regulation going on. I mean, we have GDPR, we have the Data Act, the AI Act, the Product Liability Act, the Product Cyber Resilience Act, the regulation on cybersecurity and software updates, and it keeps going. One of the companies that I work with that builds trucks that they ship around the world, they are subject to somewhere between 250 and 300 regulations that they have to support. So this is a little bit of a challenge for many of these people. But what I wanted to talk to you about is what is happening in software engineering. This is what you all recognize as the old way of doing software engineering. It is you have an intent, you generate requirements based on that intent. Out of that, you design an architecture or some kind of software design, and out of that comes code. And out of that code, you then put in operation that becomes a system in operation. If you ask me where software engineering is going, it is going to look like this in the future. We express an intent, and then some set of agents will take that intent, turn it into quantified outcomes, generate a set of requirements out of those outcomes, generate an architecture and a design out of that system, so the code, and that then leads to a system in operation. Yeah, the whole notion that we're going to be sitting there coding is, I think, going away very, very rapidly. And anyone who's using any of the modern tools is probably realizing that as we speak. Yeah, and I have lots of examples. Actually, I was in an interview yesterday with someone from a large German company, something in common with my last name that I will not mention. Yeah, but basically what they did was they basically now have an enterprise architect and a set of AI agents, and the enterprise architect basically does not need any developers anymore because the agents have taken it over for him. Yeah, so that's where we're going. How is this going to happen? Well, at the operational level, we're going to have reinforcement learning, I think is one of the big techniques. And at a higher level, it's going to be about vertical AI agents. Yeah, agents that have a specific job to do a specific task and generate the things that you need to have. And I think it's important to think about this. I mean, the world is really changing very, very aggressively. And every company that I work with is trying to figure out how to do this. We are no longer building systems. We are going to grow systems. Yeah? Out of this comes a system, and then we give it some more input and say, well, we didn't quite mean it like that. We actually meant it more like this. That's what I see the world of software engineering going. And that's why we have the title of the presentation. Of course, we're not there yet. So what I now see is that many of the companies are looking for a way in which, how do we connect those two things? What do we do offline? What do we let humans do? What do we do online and let the system do? Those are, I think, the questions that we're currently struggling with. And then, of course, I had to ask ChatGPT, what does the fabulous future of AI-driven software engineering look like? And this is what he comes up with. Yeah, and I showed this to some of my colleagues, and they said, oh no, we're still in offices looking at computer screens. I mean, that person thought it was pretty boring. Yeah, but in any case. So 3 takeaways, because I think that many of you in this room think that we're doing pretty fabulous from a software engineering perspective. Yeah, and it can only get better. Now, I would like to disabuse you of that concept. The state, the effectiveness of software engineering, as far as I can determine today in the companies that I work with, is atrocious. It is really, really bad. Yeah. Second, in order to address this, we need to shift from what I call requirements to what I call outcomes. And we're going to talk a little bit about that. And we need to adopt AI in the product and in the development process. Those are the 3 key takeaways that I want you to remember from this talk. Yeah, so that's what we're going to do. So first, I'm going to briefly tell you who I am and where I come from. Then I'll talk about the state of software engineering, something about requirements and outcomes, exploiting AI, and then we're going to conclude. Yeah, so very briefly about me. I used to be a young and innocent professor of software engineering. Then I went to Nokia, where I got to know Ilari. I'm not sure, don't think he's here right now. About 13, 14 years ago, I moved back to Sweden and I moved back to academia. No, sorry, after Nokia, I went to Silicon Valley, worked for Intuit, for those of you that know the company and have lived in the US. And since about 10, 15 years, I'm now back in Sweden. I have 2 professorships. I run Software Center, I run a consultancy, I do some board work, and I do some angel investing, including Costly, which is now run by Mike Long. Does anyone here remember the name Mike Long? Pragma? Yeah, at least one or a few basically remember him. So that's actually what I do. My main job, however, is being director for a research center between 15 companies and 5 universities, all concerned with accelerating the digitalization capability of the European software-intensive systems industry. And these are traditional companies that have built products that have mechanical components, that have electronics components, and that have software components. Yeah, so that's basically what we do. And then I will not bore you with all the details here, but we do work on continuous integration and and DevOps and continuous test and those kind of things, architecture, technical debt management, APIs, metrics, customer data and ecosystems, and then AI engineering. Those are the main topics that we work on these days. And then why should you become part of Software Center? We can talk about that when we go offline. But what I basically do is I identify new ways of working in the pure SaaS world, and then we translate them to how do you actually do this in embedded systems companies. Yeah? And if you look at all the new developments, if we look about agile practices, if we look about continuous integration and test, if we look at DevOps, if we look at A/B testing, if we look at all kinds of different techniques that are currently being adopted around the world, they start off typically in leading companies like this, and then they trickle down to the rest of the industry. So that's basically what I do. State of software engineering. There is a very big elephant in the room when it comes to software engineering. Here is the belief of every engineer that I meet. I get a requirement spec from the customer. I build what it says. I test it, and I deliver the system based on the requirement spec to the customer. Of course, the customer is happy, right? Wrong. You've all seen this graph, I think, many moons ago, yeah, by Standish Group, that basically shows that in a typical system, somewhere between half and 2/3 of all the requirements in a typical system are never used or used so seldomly that the R&D effort that went into building them wasn't worth it. A few years ago, we repeated this study with a company in the Gothenburg region in Sweden that after they saw the data, decided that they wanted to stay anonymous. Funny how that works. But what we see is exactly the same pattern. We have all the features on the x-axis, we have the number of times a feature is used on the y-axis, and we see the same pattern. Some features are used all the time, some features are used occasionally, many features are never used. Yeah, so my conclusion is that half of all the new functionality that we built is waste. Because understand me well, this is not a feature like the airbag feature in my car. I hope that the airbag feature in my car is never activated, because if it is, I would be in an accident, or one of my family members would be in an accident. These are features where product managers stood hopping up and down in front of a prioritization meeting saying that unless we get this feature, we're all going to go to hell in a handbasket. And you get it prioritized, it gets built, it gets released, and guess what? Crickets. Nothing. Yeah, how cool is that? Now, as you probably already figured out by now, I've been going for 9 minutes. I'm not a very smart person, so I can only do very simple models. This is the model that we call the 3-layer product model, which says that every product, every platform, every framework has 3 layers of functionality. A layer of commodity stuff that no customer gives a flying hoot about. Yeah, it should just work. It's been in the previous releases. It's already there. Don't do anything with it. A layer of differentiating functionality, stuff that makes the product special, yeah, that makes your customers pick you over a competitor. And then a layer of innovative and experimental functionality. And you know how it works. I mean, you start with innovating something, customers really get traction of it, it becomes differentiating and becomes part of your differentiating functionality layer. And then after a while, it becomes commodity and it basically slides down into the commodity layer. Yeah, so what I have now asked well over 50 companies, What percentage of R&D in your organization goes into commodity functionality? And what percentage of R&D goes into differentiating, innovative, and experimental functionality? You want to know the answer? As far as I am able to determine, based on self-reported numbers from these companies, somewhere between 70 and 90% of the typical resources in a company, R&D resources in a company, go to functionality that no customer gives a flying hoot about. Should just work. It was already there. And why is this? Well, there's an update of some external software. There's all kinds of excuses of why this is happening. Often it's also that people inside the company think it's still differentiating and it isn't anymore for customers. Yeah, but what we see, and this is my conclusion about the current state of software engineering in industry, is that 7 to 9 out of every 10 people in R&D work on stuff that no customer cares about. It should just work. The 1 or 2 that build new functionality get it wrong half the time. Yeah, hence half or 2/3 of all the new features are never used. Yeah, and if you translate this into a cost and value game, yeah, you can take pictures, but there will be more on this slide. It's a build. Yeah, if you have a company, most companies allocate their R&D budget as a percentage of revenue. Yeah, so in this case, I took a company that allocates 5% of its revenue to R&D. You're with me so far, right? You know how 5% works. Okay, I'm not getting much of a reaction here. I'm not sure. Is this too complicated or did I hurt your feelings? This is a funny thing. No engineer wants to talk about his feelings or her feelings for that matter. Yeah, so the question that I then have is, for every euro that gets invested in R&D, how much revenue should be generated out of that euro? You want to know the answer? 20x. R&D percentage is 5%. That means that every euro that goes into R&D has to generate 20 euros of business value. Now, let's take this into a number. I have an 8-person team. I have a 3-week sprint, meaning I spend 24 weeks of effort every sprint with that 8-person team. Yeah, if I'm assuming that an FTE costs 200,000 euros, which of course in London is way too low, right? Okay, not everyone is agreeing with that statement, but let's not go there right now. Yeah, then basically you're burning in terms of cost, every sprint, you are burning 100,000 euros. With me so far? How much value do you have to create during that sprint? Well, the answer is very simple. 20 times 100,000, which is 2 million euros. Yeah, so if you want the economics of R&D to go together, every agile team, every agile sprint has to generate 2 million euros of business value. In a context where 7 to 9 out of every 10 work on commodity stuff, and the 1 or 2 that build new stuff got it wrong half the time. Can you see that I am slightly concerned about the effectiveness of R&D? Are you still here? Is this something you care about? Because I do. I mean, in the end, we're in a for-profit business, right? We have to do what we can to generate maximum value from the R&D effort that we are creating. I think that's obvious to everyone in the room. You may not like to think about it. You prefer to think maybe about empowered teams and all this other good stuff. But if we don't deliver business value, no one cares about empowered teams. It's very simple. What's the problem? I think requirements are the problem. If I look at the companies that are the most mature in how they link the value created by R&D teams to business outcomes, they create something that I refer to as a value model, where basically you have top-level business factors, the KPIs that you have as a business, that get translated into product and system-level factors, that get translated into team-level factors. If I look at the companies that we worked with, companies like Microsoft, companies like Booking, Skyscanner, and others that we've worked with, they tend to work in this way. Yeah, when I worked with Booking in the 2010s, every agile team, every agile sprint knew exactly how much money they made for the company, because they know which were the KPIs, and they knew that if in their part of the architecture they were able to shift the needle a little bit, they knew how much money they made for the company. Yeah? Now, I don't have time to go into this, But the interesting thing is I have a whole process and there's reference, and if you want to talk to me afterwards, come and talk to me. But what I noticed is that in almost every company that I work with, teams have very little agreement and understanding of what the measurable KPIs are that would constitute a successful realization of the functionality that they're building. Yeah, this is from a Swedish automotive company that shall remain unnamed. And we were discussing the adaptive cruise control feature in the vehicle. Are you still with me? You know adaptive cruise control, right? You have a radar, you have lane keeping, and you basically have adaptive cruise control. That's a feature that has been in the vehicles for well over a decade, has cost well over 100 million Swedish SEK to realize, actually significantly more than that. And now we sat down with the team, these were about 15 people, I think, to discuss what quantitatively constitutes a successful adaptive cruise control system. How do you measure success? Guess what? 15 people. No one agreed what a successful adaptive cruise control system like. There are some people talk about how often it's used, how often it's used at different speeds, how often a driver interacts with the system. All kinds of different KPIs came up. So imagine a situation where you have a 15-person team and not a single engineer agrees with everyone else of what success would look like. What do you think the consistency and alignment of the feature realization is in that context? Yeah. So this is, I think, the first one. You have to translate. We actually have one company now that I, again, cannot mention, where every time product management comes to the team and says, we would like to have this functionality built, the first question the teams asked, what is the outcome that you're looking to accomplish? How would we know that we deliver success? Yeah, so that is the next thing, and that's what we see in AI as well. You cannot do a lot of things if you don't know what you're looking for. Yeah, you end up in an Alice in Wonderland situation where she asks the Cheshire cat, where am I going? Where should I go? And then the cat asks, well, where do you want to get to? And then Alice says, I don't care. And then the cat says, then you can take any road you want. Then it doesn't matter, right? You need to know where you want to go. Yeah, so here, this is the HyPEX model, where you take a feature out of the backlog, and the first discussion between you and product management is, how will we quantitatively know that when we build this feature, we have achieved success? What is the behavioral change in the system or the behavioral change in the customer that justifies us investing this kind of money? And then what you do is you build the minimal viable feature. I first called it, which is now in the startup world, the term to use, minimal lovable feature. But I've realized that no engineer wants to talk about their feelings. And they certainly do not want to talk about love, is my experience. Yeah. So minimal viable feature. You build the first 10, 15% of the feature. You measure what is the impact of this thing. And then you have 4 possible outcomes. One is nothing happens. And what you should do is you should ditch the feature, remove from the code base, move on with your life with the next feature. Another one is you build 30%, you get everything you wanted. Then you don't have to build the rest of the feature. Just move on with your life. You already got what you wanted. Yeah, sometimes you get really funky feedback, and when you start to interview users and you ask for quantitative feedback, what you'll see is that basically they want the functionality, but not in the way that you build it. So you have to re-implement it. Or yeah, maybe you have a way where you are gradually increasing the quantitative output that you're looking for. Yeah, that's one of the ways in which you can work with this. So that's what we call the HyPEX model. I assume everyone here knows A/B testing. Yeah, so I'm not going to talk about that, but that's again a very effective way where you can figure out what's the right way of realizing functionality so that we're actually delivering the value that we're looking for. Yeah, so those are the kind of things that we're looking at. What I'm now going to show you in the last 10 minutes is a little bit of progress that we've made in this area over the last years. And the first is, this is a kind of in-progress maturity model of how companies work with AI. Yeah, and this is not R&D, this is the company as a whole. So the first is, we see, based on interviews with about, I think now 10 or 15 companies, roughly 5 stages. This model is still under development, but we're still looking for ways in which we are capturing the maturity of these companies. So the first step is playtime. Yeah, everyone and their brother is using ChatGPT or some other LLM for trying some personal productivity tasks. Anything from test case generation, email generation, documentation generation, those kind of things. The next step is automation 2.0. We have a process. The process has a sequence of steps. One of those steps we have not been able to automate. Now we're going to try to automate that step in the process using an LLM or something else. Yeah, that's the second step. The third step is the local AI first. Then I take a business process, I re-engineer the entire business process beginning to end in an AI first capacity, but that business process is re-engineered in an isolated fashion without connection to other business processes. In the fourth stage, you move towards super agents. Then you have the multiple business processes and they are starting to get connected to each other. And you have agents that coordinate the work in the different business processes in order to improve outcomes. And then finally, what we call the AI-driven organization. That's when an organization is basically completely top to bottom re-engineered from a AI first perspective. So every business process, every aspect of a company is basically developed like that. And then when you have that, you move towards a model that I call the, we call it quote unquote, the algorithm. So all automation in a company, all traditional automation, all AI-driven automation is one layer in the company. And then you have humans below the algorithm. They work for the algorithm. Think the Uber driver, or the accountant for that matter, who also gets told what to do. And then you have people that work on the algorithm, the people that improve the performance of the machinery that is basically in the algorithm. So that's how we're thinking about that part. The other is, if you look at AI-driven products, the first step is the AI system, individual developers playing around with different... I'm actually looking at the gentleman over there who's hanging over the side of the building. I'm not sure what he's going to do, but it looks pretty scary, I must admit. Sorry, now I got you all moving in the other direction. That's how I felt giving this talk, let's put it like that, right? Yeah, so that's the first. You basically use it in your own test case generation, code completion. I mean, you've all used Cursor and other kind of tools, so you know about that. Second is AI compensator. Yeah, I have a team. The team is doing some work. They lack skills in a certain area, and rather than getting additional people in, they basically go and get an AI agent in, a little bit like the previous talk with the DAISY model. Then you move towards the AI supercharger. That's where an individual and a group of AI agents can basically replace an entire team from a productivity perspective. And this is not the future. This is happening. I literally was in a meeting yesterday where someone brought up that in this company, they were thinking about having a enterprise architect and a team of 5 developers basically building this whole solution. And they figured out that they only needed the enterprise architect, and they had 5 agents that were basically building the system. And the enterprise architect was basically overseeing the work. That's what we're seeing. The next is AI operator. Then you start to put AI in the product, think reinforcement learning. And then finally AI first, when you have basically the vision that I started this presentation with. I have 7 minutes left, but what I do want to stress is that this is part of a trend that has been going on for decades. How do we deliver value to customers? It used to be product generations. Yeah, you saw that I have AB Volvo, the truck company, and Scania in the software center. They basically go through 7-year platform cycles. Every 7 years, there's a major new update of new value being delivered. Then we move to annual software updates. All of you that are old enough to remember this, the next version of Oracle or SAP or something came in. You had to basically install it. Nothing worked for several weeks, and then you were fixing all the different things. And then it started to work again. Then you could go back to sleep for another 48 months or something, or weeks like that. Now it's DevOps, DataOps, MLOps, etc. All the topics that we're talking about here, but it won't stop there. A/B testing in many contexts where we've seen that being used can give you new value within hours or days. And then the final one that I currently see on the agenda is what I refer to as reinforcement learning, where you're basically having algorithms in the system where the system fully autonomously experiments with its own functionality to get better. And you basically tell it, this is your search space, this is your state space, this is your actions page, this is your reward function. Go and figure out what is the best way of doing things. Yeah, that's what we're seeing happening now. So if you ask me what is the future of software engineering, we call it the holistic DevOps model. Yeah, which is basically we will have traditional requirements-driven development for regulatory compliance, competitive parity features, commodity features. We still need some of that. Probably very much driven with AI agents, but still. Then you have outcome or data-driven development. In an outcome-driven development stage, you get into a situation that I noticed when I worked with some of the people at Booking. You are a team responsible for one part of the website, and conversion at your part of the website is 3.2%. Yeah, so that means that out of every 1,000 people, 32 people do what you want them to do, and the other 968, if I calculated correctly, are not doing what you want them to do. And now what you get as a team is an assignment. Your job from the coming quarter is to get conversion from 3.2 to 3.4%, and I don't care how you do it. Are you with me? Yeah, so then you don't get requirements, you get an outcome to strive for. And then the last one is AI-driven development. I have large data sets. I generate or train a model, or I get something from Hugging Face and I do some fine-tuning, but you basically get this. All of these things will generate behavioral data, will be subject to DevOps, and that's how systems will look in the future. A few years ago, we developed something that we call the AI engineering agenda, and I don't have time to go through all of it because it's way too big. It's actually a full day thing. But one of the things that I am super excited about is automated experimentation. Reinforcement learning, where systems experiment with their own behavior in order to get better. Yeah, we've done quite a bit of work on that. We worked with a Swedish telecommunication company starting with an E. Sorry, Ericsson, in case you were wondering, where we basically got the opportunity to experiment with some of the parameter settings in a radio base station in order to figure out how to optimize the performance of the system. Yeah, so we use multi-arm bandits and other kinds of approaches. Then we have end-to-end federated learning in real time, where we had multiple vehicles that were together. Each of them was individually training a model on steering wheel angle prediction, and they were exchanging knowledge with each other, basically a typical federated learning approach. A third case is what we refer to as flying base stations. In a disaster area, if something really bad happens in a certain part of the world, the base station in that area is often destroyed, but you still need network connectivity for rescue workers and for others. So what one of the companies that we work with has developed is basically a flying base station, which is a drone. And that drone basically hovers over the disaster area, provides network connectivity to rescue workers on the ground, and a back channel to the next nearest base station. Are you still with me? Positioning that flying base station in the optimal space so everyone has optimal connectivity and enough back channel is actually a really hard problem that has to be done real time. So we use reinforcement learning for that. And when we were able to do it with one base station, with one drone, we basically moved towards multiple drones, where multiple drones together are jointly figuring out where to position each of the three of them in this case, in order to have maximum bandwidth and connectivity between the things. These are situations where the functionality in the system is not algorithmically programmed in. We're basically saying this is your action space, which is where you can position yourself. This is your reward space, a balance between back channel and uplink channel throughput. And each of these is basically optimizing itself and the others in the algorithm. So I think that that's pretty cool stuff. I have 2 minutes and I want to briefly talk about this. I'm not sure who has seen the video by Pekka Abrahamsson about the snake game, but it looks a little bit like this. Basically, the prompt is, build me a snake game in Python. And then all these agents start to work. And guess what happens and what comes out at the end? A chunk of Python code that when you put it and execute it, it basically represents a snake game that works. So it's pretty cool. This is the vision that I was talking about in the beginning. There's another one also from Finland for whatever reason, CodePotty, which is the same way. You basically have the manager agent and a bunch of developer and testing and verification agents that together fully autonomously, without any of your help, are basically creating the source code that you're looking for. Pretty cool, eh? Come on, people. This is cool. This is cool. I think that this is really awesome. So conclusion. The effectiveness of software engineering today is atrocious, and it's your fault. Sorry, maybe that was not the right way of putting it, but it's very easy to think, we're doing great, we're doing awesome, and it will only get better. No, that's not true. The effectiveness of software R&D is really, really poor today. If you look at the value that we are creating as a community, I think it is pathetic and we need to step it up. And it's not just the fault of the engineers. We also need product management and much more enlightened, higher level management in organizations in order to improve that. Yeah. Second, let's stop talking about requirements. I have sometimes mentioned that requirements are the root of all evil. Maybe that's too harsh, but we need to stop talking about requirements and start talking about outcomes. I'm out of time, so I'll stop. And then we have to get AI in the product and in the development process. Are you with me? Or are you against me? Yeah, you know people, George Bush, you know George Bush? Yeah, you know people with my last name, when they moved to the US, you know what they renamed themselves into? Bosch became Bush. So I was worried that I might actually be related to the guy. But then Trump came and I thought, who cares? Okay, never mind. Yeah, I have a very bad hobby. I write books. If you go to my website, which is on the next slide, you can download, except for the one in the upper left, you can download the other ones for free. Yeah, which is about the 3-layer product model and using data and how do you go through digital transformation, all this other good stuff. Also something on platforms if you're interested in that. And with that, I would like to thank you for your attention. And I look forward to any questions you might have. And otherwise, come and find me after the talk. Thanks.